Welcome to Aseem Dnyan Vahini. The acronym for Aseem, A-S-E-E-M, Atmanirbhar, Science, Education, Enrichment, Mahavahini. Aseem Dnyan means unlimited knowledge. Aseem is for empowerment of educating skills. Aseem is for organization of science quiz contests. Aseem for science education short film festivals. Aseem for reviews on various famous science exhibitions. Aseem for talk shows on science related topics, for great meet with famous scientists, and Aseem for webinars and lecture series. The ultimate objective of Aseem Dnyan Vahini is science popularization.
The NCSC 2020 was held online. In this year, 191 projects were registered for first level of Mumbai District Children Science Congress. On the basis of Synopsis evaluation test of all these 191 projects, 102 projects were selected and called for project video and project report book evaluation round. From this round, 65 projects were selected for live oral presentation at Mumbai level, from which 20 projects were selected as best projects from Mumbai and were sent to state level. We feel proud that our project was among the selected projects for state level. On 31st of January 2021, we presented our project for state level on Zoom meeting. I am happy today to present the same video here in front of you. Aseem Dnyan Vahini is presenting the series of these 20 videos. This is our small step for science popularization and for documentation of good projects for future child scientists.
Morning to one and all. Myself, Master Amit Vikmani, and my partner Shubham Dubey. We are from Cosmos English High School, and today we are going to present our project. The topic of our project is sustainable utilization of pineapple waste and converting them into vinegar, organic stain remover, and bioaerosols. As we all know, the increased production of pineapple atoms has led to massive production of waste. This leads to serious environmental problems. This is mainly due to selection and elimination of components unsuitable for human consumption. It causes air pollution, eutrophication, soil pollution, etc. In order to overcome with this problem, we have come up with methods that utilize low economic value waste, pineapple waste, and convert them into vinegar, bioaerosols, and organic stain remover under the theme Science for Sustainable Thing and sub-theme Appropriate Technology for Sustainable Living.
Aims and objectives of our projects are to prepare organic vinegar from pineapple waste, to check the pH of vinegar by red cabbage solution, to check the acidity, percent of acetic acid in the vinegar by titration method, to check the antioxidant activity of vinegar and compare it to commercial vinegar by DPPH-SA method, to check the antibacterial activity of vinegar against SRS bacteria, to prove the effectiveness of pineapple peel as a stain remover, to prepare bioaerosol from pineapple leaf waste. Hypothesis of our projects are pineapple peel waste can be fermented to make highly nutritious vinegar. The pineapple peel extract, due to its acidic material, can be a prospective stain remover. Pineapple leaves, being fibrous in nature, can be used to make bioaerosol.
Experiment number 1. Our aim of experiment number 1 is to prepare organic vinegar from pineapple peel waste. Organic vinegar can be prepared by two-step fermentation of pineapple peel waste. Procedure: 2 jars label A and B were taken. In both the jars, 1.2 liter of filter water was added. Then half a cup of jaggery was added in both the jars. Along with 1 waste of whole organic pineapple was added. In jar B, yeast was added too. Both jars were kept for fermentation. Observation: after 2 weeks, the pale yellow color was obtained in jar B, and after 3 weeks, the pale yellow vinegar was obtained in jar A. The following parameter was analyzed for both vinegar. 3 parameters were used, that is color, odor and taste, and we got the same result with yeast and without yeast. The color was pale yellow, odor was tarty and taste was sour. Fourth parameter was used to check the pH of our vinegar. Ideally, the pH of the solution is checked by using pH meter or pH probe. But however, due to lockdown and alternate home remedy, red cabbage was used for check the pH of our vinegar.
Which contain flavin molecules called as anthocyanin, which impart violet color to it. Anthocyanin is highly sensitive to pH and gives color indication when pH is altered. An acidic solution gives red color, neutral solution gives purple color, whereas basic solution gives greenish yellow color. An indicator of red cabbage is made by adding grated red cabbage in hot water. This is constantly stirred until it cools down and then stirred. Then the obtained solution is added to sample to check its pH. Lemon juice and detergent were used as acidic and basic controls respectively. Result: the color of sample solution turned red, which indicates the pH of the solution being 2.0. Fifth parameter is to measure the amount of acetic acid in the vinegar by titration. Solution in the burette was 1 normal sodium hydroxide. Solution in conical flask was 5 ml of vinegar. Indicator was 2 drops 0.1% phenolphthalein. After titration, an end was obtained when the colorless solution in the conical flask turned pink. This procedure was repeated thrice. The amount of sodium hydroxide to titrate vinegar was found to be 3.7 ml. The same procedure was conducted for sample analysis for both the jar, that is jar A and jar B. Result: with the help of this experiment, we have determined the concentration of acetic acid in the vinegar is 4.5%.
Parameter is to check the antioxidant activity of vinegar and compare it with commercial vinegar. It has been found that vinegar has a substantial antioxidant effect which aims in protecting functional organ against oxidative stress. To check the presence of antioxidants, an calorimetric assay is conducted using DPPH, 2,2-diphenyl 1-picoyl hydrazyl hydrate as a reagent. Add 5 ml of 0.2 millimolar DPPH solution to 4 ml of ethanol and 1 ml of sample. Mix it well for 30 seconds. Incubate at room temperature for 30 minutes. Absorbance of the sample is recorded against ethanol as blank at 570 nanometer on calorimeter. Result: from this experiment, the percentage of antioxidant determined and it is estimated to be 20 to 30% from pineapple vinegar and 10 to 20% for commercially available vinegar. Conclusion: from this experiment, we can conclude that pineapple vinegar shows more antioxidant property than commercially available vinegar.
Parameter is to check the antibacterial activity of vinegar against Asaurus bacteria. We have been granted permission for conducting this experiment post-lockdown at RJ College Ghat, Kopar. Procedure: bore 3 wells in the agar equidistant to each other. In first well, take pineapple vinegar jar A, and in second well, pineapple vinegar jar B, and in third well, ampicillin, which is controlled. Incubate for 24 hours. Observation: the zone of innovation for pineapple vinegar jar A is 17 mm and for pineapple vinegar jar B was 17 mm. Result: the zone of clearance observed indicating Asaurus bacteria to be sensitive to the sample solution.
Final conclusion of experiment number 1. Vinegar was formed from pineapple peels using fermentation technology. Addition of yeast fastened the procedure. However, the properties of vinegar formed were not altered. The antioxidant property of vinegar formed can found to be better than that of commercially available vinegar. Along with this, vinegar was found to be antimicrobial against Asaurus bacteria.
Number 2. Aim of experiment number 2 is to determine the pineapple peeling as a stain remover and compare it to commercial stain remover. Procedure: waste pineapple peel is weighed and chopped finely. Put inside a clean white cloth. It's squeezed to extract the juice. Same procedure was conducted with salt added in the ratio 2:1. 4 types of stains were used in this study. Grease, ink, rust, mud. Each stain was spread in the white cloth. Stains were allowed to stain the cloth for 10 hours. After 10 hours, each stain was treated with commercial stain remover, pineapple peel extract with salt, and pineapple peel extract without salt for 10 to 10 minutes. After that, rinsed under running water and stained clothes were analyzed. Result: there is no significant difference between the stain treated with commercial stain remover and pineapple peeling stain remover. Conclusion: the cost of pineapple peeling stain remover is much lesser as compared to commercially available stain remover. Survey should be conducted to check the efficiency of pineapple peeling stain remover with salt and without salt.
Experiment number 3. Our aim of experiment number 3 is to prepare bioaerosols from pineapple leaf waste. Procedure: Part 1. To extract pineapple fiber from pineapple leaves. After harvest of the pineapple fruits, the plant leaves are separated from the trunk. The fibers are manually detached from the leaves by a method called scarping, known as decortication. The process is done by soaking the leaves of pineapple into the water in a certain period of time, such as a week. Scarping with a plate non-sharp knife to remove the skin leaves attached on the fiber of the upper surface. All that fibers is washed with water and dried under the sun or using the
Part 2. Fabrication of pineapple fibers aerosol. The pineapple fibers are blended for 5 minutes using a blender to cut long pineapple fibers into smaller ones. 2% weight of pineapple and 0.2 gram of PVA, polyvinyl alcohol were added in 100 ml of deionized water and mixed. Then the obtained suspension is sonicated by prop sonicator at 200 volt for 10 minutes to enhance homogeneity. Then the obtained mixture is cured at 80 degrees Celsius for 2 hours. After curing pineapple fibers, aerosol sample is frozen at minus 18 degrees Celsius for 24 hours. Then the frozen mold is freeze-dried using a freeze dryer.
uses of bioaerosols. Bioaerosols can be used in preservation of foods and wastewater treatment and is very much cheaper than commercially silica aerosols. Result: bioaerosol can be prepared from leaves of pineapple plant. Final probable conclusion: in this study, environment polluting byproducts, pineapple waste, peels and leaves could be converted into vinegar, organic stain remover and bioaerosols with higher economic value than the main product by appropriate technology. It is an important step towards sustainable living to build creative and innovative thinking about helping the environment and preserving nature.
Validation of hypothesis. Highly nutritious organic vinegar is prepared from pineapple peeling. Pineapple peel is a very effective stain remover. Pineapple leaves is used to make bioaerosol.
Objectives of our project are: step towards sustainable living, eco-friendly and non-toxic. Third, cost-effective. Future scope: in order to check the efficacy of pineapple waste stain remover, in order to check the efficacy of bioaerosols. Thank you.
We thank Ministry of Science and Technology, New Delhi, NCSTC Network New Delhi, Jigyasa Trust, Thane, Navnirman Vigyan Prabodhan, Mumbai, Education's Inspectors of South, West, and North Mumbai, for their support and guidance.